Hi, today we're going to talk about factoring special cases. Sometimes factoring a trinomial is a lot easier than others. So we're going to see just what works and what doesn't work in some really great opportunities. So let's get our name on the paper. Keep your work to you so you don't lose it and no one takes it. So let's start by remembering our special case of multiplication. So we worked on this a few lessons ago where we had this one binomial squared. And we could work this two ways. When we did this, we had the opportunity to decide, okay, the squared means do it all twice. So we can write it out twice. And then do the FOIL multiplication from here. So first, 2x times 2x is 4x squared. Outer, a positive times a positive is a positive. 2x times 3 is 6x. Inner, a positive times a positive is a positive. 3 times 2x is 6x. And then last, a positive times a positive is a positive. 3 times 3 is 9. And after we did this, we remember that we have to combine like terms that are here in the middle, and we walk away with 4x squared plus 12x plus 9. Now that was one method that we could use to do this multiplying, but it does not show the speed with which we could have gotten our answer, just because this is a special case. So let's rewrite it and find a faster way. Let's remember a faster way of how to do this. So we started with 2x plus 3 squared. And our trick, our helper, was that if we had a plus b squared, that was the quantity of a squared plus 2 times a times b plus the quantity of b squared. Do you remember that? I hope so. So let's use it for this particular problem. So my quantity of a, this is a, this is b. Oops. So 2x squared plus 2 times 2x times 3, because this is my a, this is my b, plus my b squared. So 2x squared, 2x times 2x, 4x squared, plus 2 times 2 is 4, 4 times 3 is 12x, plus 3 squared is 9. And check it out, that's the exact same answer that we got doing FOIL, just with less work, I would say. So it is using this method that we want to explore a possibility of moving backwards, factoring a whole lot faster. So what we're looking for is, when we're handed a trinomial, is the first term a perfect square? Is the last term a perfect square? Because if they are, most likely this will be what's going on in the middle term. How do we trust that? Well, these problems were handed to us under the presumption with the desire that they're going to work. Yeah, they want, the people who wrote this want these problems to work. So we're going to assume most of the time that they do. And we can always check it. I mean, sure. So the question you ask yourself is the first and last a perfect square? That's the big question to answer these problems. So let's do this example real quick. First term, is that a perfect square? It sure is. 4x squared. What would that have come from? Well, 4 comes from 2, x squared comes from x. Great. My last term, 9, is that a perfect square? What would that have come from? 3. So, therefore, the factored form of this trinomial is 2x plus 3 squared. Done. That is super fast. I mean, crazy fast. Love those. Because it was just that easy. All right. So let's check out this next one. So we'll even split this off to say they're going to give us another thought for us to think about. We can multiply this and do the FOIL. FOIL always works. I mean, when in doubt, do the FOIL. And then maybe you can start seeing and remembering the pattern again. And I'm going to rewrite it just because I have to use this more than once. So I've got 2x plus 3 times 2x minus 3. FOIL. Here's my first, 2x times 2x, 4x squared. Outer, a positive times a negative, it's a negative. 2x times 3, 6x. Inner, a positive times a positive, it's a positive. 3 times 2x is 6x. And then last, a positive times a negative is a negative. 3 times 3 is 9. So what happens when we combine like terms? This is a negative 6 and this is a positive 6. They cancel out. That's right. So I get 4x squared minus 9. There it is. That is the long, drawn-out, foiled version. So let's see if we can remember the rule that they had given to us. So the rule was, if I have a plus b times a minus b, then that just creates the quantity of a squared minus b squared. That's all it is every time, which is really nice. So let's do that with this particular example. 2x plus 3 times 2x minus 3. So I have the same front and last term in each binomial. I have a positive in the middle of one and a negative in the middle of the other. So I can use this rule. A is 2x, I'm going to square it, minus b, which is 3, I'm going to square it. 2x quantity squared is 4x squared, minus 3 squared is 9. And hey, that was the exact same answer as when we did FOIL. It just came faster. Yeah, it was pretty great. So now let's work it backwards. And this is going to be our difference of two squares. So with the difference of two squares, is the first term and the last term a perfect square? Are there only two terms? And is there a minus in the middle? So we have more questions this time. So let's write down our questions real quick. So question 1, are there only two terms? Because there has to be just two terms. Question 2, is there a minus in the middle? Last question, are both of the terms perfect squares? If that is the case, we can even set up the two binomials. It'll be the square root of the first. I guess we'll put first. We have a plus, we have a minus, we have the square root of the last. Square root of last. That's what we're doing. So let's apply it really fast, super easy. Asking the questions. Hey, are there just two terms? Yep, 1, 2. Is there a minus in the middle? Yep, right there. Are both of the terms perfect squares? Yeah, because 4x squared comes from 2x, quantity squared. 9 comes from 3 squared, because these are the square roots of those terms. That's where it comes from. All right, so let's do it. So I have my first term, 2x, 2x. I have a plus, I have a minus, and I have my second term, 3, 3. Done.